This conference will now be recorded.
Okay, so like this, I have created 3 joints. Okay, so in between them we need to apply one more coupling joints, but we haven't created that. See, I'm going to delete this mechanism. Okay, so all the mechanism has been deleted. There is no more mechanism in it. Okay, so now I'm going to create a new mechanism. Insert mechanism. So now a new mechanism has been created. Here it is asking joints, commands, loss, and speed acceleration. Now I'm going to create fixed component. So this is my, so see, these 3 cylinders are going to be up needed for rotation. So this rectangular block is my fixed component. Either this block or this block we can make the fixed component. So with respect to another one, this one also I am going to make fixed, but instead of fixed, I am going to use rigid. Okay. So with respect to this one, I am going to make this one as my rigid. Click on OK. So now I have applied this fixing. Next one, I am going to apply CV joint. Okay. So click on CV joint. So it is asking spine 1, spine 2, spine 3 as its inputs. Okay, center axis of first cylinder, second cylinder, third cylinder is its spines. Okay, click on OK. See, remember, up to now, we have given joints, 2 joints. One is rigid one and second one is CV joint. And see, we don't get to apply any commands. Okay, so now what I'm going to do, I'm going to apply one command, which is nothing but, so this cylinder, I need one driving cylinder. Okay, the power source. So I'm going to apply this revolute joint. You know, revolute joint requires line 1, line 2, line plane 1, plane 2. So this is the line 1. I'm going to hide this part, rotate this one. This is the line 2. Next one, plane 1, plane 2 is nothing but just unhide this one. So I'm selecting these 2 faces. Now I'm giving the command as angle driven. Click on OK. See, now the command is there. Command is there, and it is nothing but revolute joint angle. Okay, let's check whether this complete mechanism can be simulated or not. See, it cannot be simulated. Why, ma? Let's see. So some joints are not well positioned. So it is not showing the accurate problem of this particular mechanism. So let me think. So now I have given this exact rectangle as my fixed component. So if with this support, I'm going to I have applied revolute joint for this particular first cylinder. Okay, up to here every connectivity of the mechanism is clear. Next, after revolution, this revolute force, rotating force, is going to follow these 2 links by CV joint. So now I have applied CV joint also. Okay. Next what? So this cylinder, I have applied this rectangular box as my fixed component, right? But there is no relation in between these 2. Okay. This cylinder, end cylinder to this rectangular box, there is no relation between them. Okay, I need to make a relation. So this cylinder is going to rotate inside the rectangular box with the support of rectangular block. So what I'm going to do, I'm going to apply a cylindrical joint. So this is the cylindrical object. Hide this part, and this is the axis. Click on OK. Remember, we are not giving any length driven or angle driven because we don't need power source. Okay. just we are going to apply the support, the link connectivity of mechanism. See, information has came. What is the information? The mechanism can be simulated. Okay. So next, I'm going to check my mechanism analysis. See, mechanism can be simulated and degree of freedom without command is 1 and with command is 0. Okay. So now I'm going to apply simulation and hide this part. Apply the simulation. For this entire 3 links, we are only applying power generation for one shaft. Okay. See, I'm going to apply 360. Now insert, just decrease the frames, unit direction rotation. Now play. See, continuous loop I have given unit in unit direction. So it is continuously rotating. So only power generation is one shaft. So with respect to the shaft, remaining two connective shafts are going to rotate. Okay. So this is my CV joint. Okay. When you are giving a joint, make sure that you are giving connectivity link. So if you forgot one of the connectivity, so it won't be ready to simulate. Okay, the mechanism is not completely perfect. See, for example, I'm going to delete this cylindrical joint. Okay, so I have deleted my cylindrical joint which is applied between this last cylinder to this particular rectangular block. See, in the mechanism one, we have degree of freedom 4 degree of freedom. Okay, so we need to make sure that for a perfect mechanism, the degree of freedom with command must be 0. Okay, so now I'm again applying cylindrical joint. This is the axis and this is the center axis of the support. Now see, when we have applied the relation, so automatically degree of freedom became 0. Okay, like this, we can check in the mechanism analysis, or else we can check in the degree of freedom, or we can check in the simulation with command. Okay, or else we can go for simulation directly. So then it will only show one single box, which is nothing but edit kinematic joint. Okay, so like this we can see whether our mechanism which is created is perfectly alright or not. Next one, gear joint. So gear joint is nothing but now we are going to apply two normal spur gates. Okay, so if you can create your own helical gates, everything. Okay, I have created two spur gates with two supports. See the angle, there is no specific angle now. Okay, all you have is in universal joint you are going to directly apply in between two inclined shafts, universal joint. When it comes to CV joint, it is required 3 joints. Okay, you don't need to bother about the angle. Okay, whatever the angle, okay, it will apply the rotation. So here I'm going to delete this mechanism. Constraints also are there. I'm deleting it. Okay, so now this particular assembly doesn't have any constraints or obligations. Okay, So now I'm going to apply gear mechanism. For creating a gear mechanism, I need to create a basic empty mechanism. Insert mechanism. So now I inserted mechanism. So in this one, I need to fix a component. So just fix a component. So for these two gears are rotating objects. So I cannot fix either one. So I can only fix this block, blue color supporting block. Okay. So this is a fixed point. So with respect to this one, so these two gears are going to be rotate. Now what I'm going to do, I completed my fixing part. After that, I need to apply joint. Okay. So here I'm going to apply the gear joint. See, carefully observe. So in the gear joint, it is asking revolute joint 1, revolute joint 2. Okay. So for this one, we need to create revolute joint. Okay. So or else we can, if we have already created, we can take the joints to here. First, I'm going to create one joint. Revolute joint. So this is the axis. Okay. So next one, hide this part. This is the center axis. Next one, plane 2, it is asking. See, this is my plane and I'll hide this one. See, I'm going to select this face or this face as my plane. Either one. Next, click on OK and hide this part. We have selected for center axis now. So I'm going to change the placement. Or else we can give the offset value. See, I'm going to unhide this one. Click on the offset. It is 0 mm. I'm going to increase it. Control U, updating. Okay, it is outside. So once again, change the offset. I'm giving a negative. Okay. So positive value 50 I have given. I need to increase the value 70. It still need to be increased. I'm giving 100. Okay, so like this I have increased my offset distance. Okay, next one. So here I have created one revolute joint in the joint. So instead of creating revolute joint for the second one, what I am going to do, I am going to select my gear joint. Go for the gear joint. So as for the first joint, I have already created the joint. So I am selecting the revolute joint from the specification tree, which I have already created. Okay. As for the second revolution joint, I haven't created the second for the second shaft to second gear. So now I am going to create it in here. Click on create. So second, just select the axis, hide this on. So this is the center axis. Next, plane one, plane two, we need to give here. Rotate this one. I'm going to select this face and here this face. Okay, click on OK. Now I have applied my revolute joint for these two gears. Okay, next one, the ratio is there. Okay, I have taken same diameter of gears, but if I have taken pinion and gear, so I can give the ratio. So at which rate I need to increase my speed or decrease my speed. Or see here, angle driven for revolute 1, angle driven for revolute 2. There are two commands. I can select gear 1 as my power generation or else gear 2 as my power generation. I'm selecting gear 1 as my power generation. Now click on OK. See, mechanism can be simulated. So when we have given the command also, it is ready to simulate. Go for simulate. Mechanism 1 I am going to simulate. Here, insert the mechanism, decrease the frame, make it in a loop, play. Are you able to see the mistake? They are rotating but in a unidirection. Okay, so we need to change that one. Close it, delete the simulation. Okay, and even we have given the center axis now, but why it is showing outside of this? So revolute 1. I'm deleting this revolute joint one. Gear joint itself we need to delete. Once again I'm applying one. So previously when we are selecting axis, so there may be some problem. So once again, in gear only I'm going to create both the revolute joints. This is the axis. And the center axis here. Next, planes. Click on OK. Next one. create center axis and the face. Click on OK. See, we haven't given any command here. Oh my. Let's close this one. So once again, instead of clicking OK, I close the previous one. Just one more time. First one is created. Now I'm doing the second one. Center axis. This center axis. This plane. This plane. Click on OK. Now hide this, unhide this one. Okay. Now here okay. So here I am giving I have created two revolute joints and it is already completed. Next, this definition is nothing but we are going to give radius 1 radius 2 ratio, or else we can directly give ratio. I am giving angular driven. Click on OK. So up to here everything is clear, but so these two I need to change the direction here. Okay, so here observe, so there will be an axis. Okay, so these two are the gears. I'm going to give you can see rotation directions are there. The same is there. So for both, see, gear 1 is in anti-clockwise direction and the gear 2 is also same with respect to this gear 1. But when it comes to gear rotation, this would be in opposite direction. Okay, now it is in anti-clockwise direction. I need to make the other one opposite to this one. Okay, so click on the opposite, click on OK. Now go for simulation. Just put the object for your convenience. Okay, simulate mechanism 1, click on OK. So now I'm going to give my rotation. See, now it is perfect now. It is not going to crash on one another. Directly I am going to give this rotation, decrease the size, frames, in a loop, play, wait. Okay, so like this, now it is perfect now. Okay, so everything is perfect now. Exactly, it is rotating everything. So like this, we need to change the rotation direction. Okay, next one, I have created a simulation. Okay, I need to see swept volume. Swept volume is nothing but, so for example, these two are rotating objects. So which area this mechanism is completely covering it. See, we have swept volume. Just select the product, apply the swept. It is not showing. So I will show the next one. Okay. There is, if now we have applied only gears for normal two gears. So in case we need to apply rack joint, so we can apply the rack joint also. So in the rack and pinion joint, one horizontal one is there, and on the horizontal gear we are going to apply a small pinion. Okay, so this is a rack and pinion joint. So in here, remember when it comes to rack and pinion joint, so this rack need to be more linear. Okay, at the same time this gear need to be rotate angular. Okay, this is the combination of linear rotation. Okay, so previously when we applied a gear joint, those two gears are going to rotate. Both are rotating. So what happens? Simply we get revolute joint. When it comes to this one, we are going to apply one linear joint as well as the rotation joint. Okay, so for applying linear joint, we have prismatic joint. Okay, so now I'm going to delete this mechanism. Next one, there is a simulation. Okay, and constraints also. So all the constraints are for making the object to its position only. So we don't need the constraints. Even though, for example, you have one constraint called coincidence. Okay, so I'm going to convert this constraint to my mechanical joint. See, we have option called assembly constraint conversion. Okay, so now I'm creating a new mechanism. Click on OK. So what this constraint I'm going to create into my joint. So see, unresolved pair is one. Only one joint, one constraint is there. So click on OK. Auto create. Click on OK. See, one joint is formed now. Cylindrical joint is automatically completed. Okay, but we don't need any cylindrical joint. Okay, so cylindrical joint is nothing but we can rotate the object and we can move the object in linearly, but we don't need to move the object in this. We are not going to move the cylinder in this linear direction. Okay, only rotation is required, so we don't need this kind of cylindrical joint for this particular mechanism. So the only drawback when we are going to convert our assembly constraints to joints is nothing but it will automatically create a in relevant joints, okay, irrespective of our requirement. Okay, So like this, there is a coincidence. So the similar one is cylindrical joint is created, but we don't require this one. So what we are going to do? We are going to delete the joint. Okay. So not only cylindrical coincidence mark. So even planar joints, every joints are we can create by using assembly constraints. Okay, when we are applying assemblies, we are going to apply several different constraints, now, like coincidence. Okay, axis coincidence as well as the connecting joint, and the next one offset. No problem, ma. Even though we haven't deleted our constraints or we haven't converted our constraints, there is no problem with that one. We can leave them as it is. Okay. So for you, if you are very confused, in the next one I'm going to uh, leave the constraints as it is. Okay. So now I created mechanism and the joint. We don't have any joints. Now I'm going to give my fixed component. So this is my supporting component. Next one I'm going to apply. So either in the same way, directly we can go for rack joint. In the rack joint, it will ask about prismatic as well as the revolute joint. Or else we directly create it and directly insert it to the prismatic joint or revolute joint. So now I'm going to create it here. So in this prismatic joint, so it is asking line 1, line 2 and plane 1, plane 2. So I have previously explained line 1, line 2 and plane 1, plane 2 is nothing but this is my line 1 and hide this one. This is my line 2. And when it comes to plane 1, plane 2, the contacting. So rotate this one. So this is the face going to contact, and here unhide this one. See, with respect to that face, this is the face it is going to contact. Click on OK. Now one prismatic joint is completed. Next one, what we need to apply revolute joint. Create a revolute joint. So for this one, this is the center axis. I'm hiding this one. So select this center axis. For this is gear. Next one, we need to give planes, reference planes. So this is my face. Next one, rotate it. So this is my next one. Next. So here I'm going to hide this one, unhide this one. See? See. So we have selected two places. Okay. Observe. Just I will move this block to here, so you will be able to see. So we have created plane 1, plane 2. So this one is my first plane and second one plane is nothing but gear inner side. Okay. So if I select directly OK, so what will happen? These two planes are going to connect, but I don't want them to connect. I need some offset. Okay. From this face to this face, I need to create offset. Here offset option is there. So by default, it will take the distance between two planes. Okay, we have already given our position now, so it will take the 223. Now click on OK. So it won't change, it won't connect these two planes. Now we have given offset. Next one, it is going to ask, so we can give either rotating. So when I'm going to rotate this gear, so automatically with respect to the rotation, this wait, this rack is going to move linearly, or else, so I can move. I am going to give the power generation for this rack movement. So when it is moving linearly, I need my gear to be rotated with respect to rack. Okay, so like this we can give either one of the power generation, either length driven by prismatic or the angle driven by revolute joint. Now I'm giving angle driven by revolute joint. Click on OK. See, mechanism can be simulated. Here we need to make sure that our object is moving in exact direction. See, click on. So already created the rack joint. I'm going to give simulation. Mechanism 1. Here, move the object. See, when I am moving this one in one direction, it is only taking it up to here. Okay, I am going to change my limits. Okay, minus 360 is my beginning, and no, not minus 360. See, reset it. Lowest value is 0. No, highest value is 0. Lowest value 360. Click on OK. So I'm going to give like this. So now I'm going to increase more. So it needs to be 360. It is rotating 700. Okay. So when we are rotating up to here only, it is moving. Okay. I'm going to insert it. I'm not doing any loop, just playing it. See, rack is moving very slowly. So now I'm going to cancel this one. Okay. So I'm giving the this joint with rack movement. Okay. So previously we have given angle driven. No? So I don't want any angle driven. I'm going to give length driven. Okay. So in here we can give the length also. See, angle driven we need to give the values here itself. Lowest limit and upper limit. So lowest limit is taking minus 100. I'm giving it as minus 360, and upper limit, first limit, I'm going to say 0. Click on OK. See, once again, I'm going to apply simulation for the revolute only. Let's see. Okay, the same. So now I'm going to change the joint. Command I'm going to change to length driven by prismatic. Click on OK. Now see simulation. Just give the, now it is up to here only. So the value is 180. Okay. So change the second limit to 180. Click on OK. Now reset. Again, check your connection. Okay. Now I'm going to insert it. Let's play in both forward and backward the motion. Now play. Okay. Like this, we can apply this rack and pinion joint. Next one, final one is cable joint. Okay. So this cable joint is nothing but it is basically used in uh, large containers transportation like that. So see, I have simply taken two blocks for this joint for simple explanation. Cable joint. So in here we will get three parts. So three parts is nothing but one is a supporting, second one is a roller, third one is a block. Okay. So like this we have like this we have a cable joint I have created. So in here I'm not going to delete any constraint. I'm directly deleting this mechanism. The constraints are already deleted. So I'm going to enter to the assembly. Okay, for applying the constraint. See, like face-to-face contact. See, this face with respect to this face. Okay, I have simply applied one constraint for your understanding. Constraints won't affect our kinematic motion. Digital mockup, the digital kinematics. See, there is one constraint called surface contact. So now I'm going to insert a mechanism. Even though there are constraints, it won't be a problem. If we need it, we can convert the constraint into a joint. Okay. So if we don't need it, we can leave them as it is. It won't be a problem. See, now I'm going to create one fixed component. See, mechanism is completed. Now I'm going to select this one as my fixed component. So after giving the fixed component, we need to give this cable joint. So this cable joint contains the prismatic joint as well as the two prismatic joints. Okay, so we have two prismatic joints. So now what I'm going to do, create first one. So with respect to this one, okay, so I need to give the faces. This face and this face is going to contact with this face. Now it is clear. Now okay, click on OK. I have created my first prismatic joint. I need to give second joint. So create second prismatic joint. So it is asking this one is my rotated object and this one is my second line. And when it comes to faces, the object and hide this one by selecting the bottom face. So this is my contacting face. Okay, click on OK. Now I have created my two prismatic joints. Okay, so now I am going to apply. We have length driven for prismatic one, length driven for prismatic. Okay, with respect to first joint, when we are going to drag the first joint along this slant edge, second block is also follow the first one. Okay, or else we are going to drag this second one. So along the second one, first one is also going to follow. Okay, so I am going to length driven for prismatic 2. With respect to the second one, I need to move the first joint. Click on OK. So mechanism can be simulated. So my mechanism is ready. But I need to give another joint for this one. I have created some other part in here. Okay. So if we are assuming that in between these two blocks we have connected a cable, okay, for moving. So I'm going to connect this particular second block to this roller joint. When when I am rotating this roller, so I need to move this blocks to forward, and I'm loosening it. I need to move these blocks to backward. Like this, I need to give some simulation. Even without giving it, also we can give the normal simulation mark. See, I'm directly giving the simulation here. Mechanism 1, click on OK. So now I'm going to apply. So like this, insert. See, we can give the simulation like this. Okay, up to here, and again it will back. Okay, so now what I am going to do, I am going to apply this roller joint. Okay, so for this one, I am going to apply cylindrical joint is enough. This one, and rotate this object. So with respect to this axis. Okay, here I am going to give only angle driven, only rotation is enough for me. Okay, so let's check whether our mechanism is ready to simulate. No, we cannot simulate it. Just go for joints in the cylindrical joint, uncheck the angle given, click on OK. Let's see the mechanism. It is still not able to. Okay, let's check the cause. Cable connection is there. Why it is not showing? I'm deleting the revolute joint. No? Cylindrical joint I have deleted. Now, let's apply this revolute joint, this axis to this axis, and this face to this face. I need some offset. Click on OK. Let's see, check. No. See, now the mechanism can be simulated. Okay. So now I have given two commands. One is with this, I need to rotate the cylinder, and at the same time I need to move this block. Let's see. Apply the mechanism. Simulation. Now see, this is the motion of the two cable joints. Next one, I need to rotate like this, not this direction. I'm changing the direction. So when it is moving in this direction, I need to make sure that my cable is loosening. Na? So I'm giving it in an anti-clockwise direction. So insert it, both direction with lowest speed. Now play. See, okay. When it is holding the cable, the blocks will be moving forward. When it is loosening, so it will be moving downwards. Okay, like this, we can use the cable joint. Okay, so everything is clear now. Now the last one is nothing but axis based joint. So this axis based joint is nothing but in this joint we can create any kind of joints. See, joint types are there. All the basic joints are there. U joint, prismatic joint, revolute joint, cylindrical joint, spherical joint. Like every joint is there. So only the basic need is we need to give two axis system as reference. Inputs are axis system. Okay. So basically we don't rare case only we are going to use, and we have seen the see let's see. Okay, for creating this step 2 also we need to create a replay. So in the simulation we have created, I'm going to create a replay. Just create our replay. Now replay is created. Now I'm going to apply the swept volume. See, so selection is replay one. Next one, product to sweep. 3 products. Next, see, review. So this is the total uh, swept volume. Okay, this red color block is going to move up to this side to this side, and same time this color block is also moving. Okay, this is the total length of the object. They are moving in its own direction. Okay, so these 3 are the objects which are rolling like this. So like this we can see the swept volume, which is the total area it is covering. Okay, for example, I am going to apply wrapping preview. See, this is the wrapping. Okay, total those blocks are completely wrapping. Okay, or else apply simplification preview. Okay, this is the simplification, and spatial split. It will take some time. Okay, so in between the distance of 2 blocks, spatial split. In between, it is going to separate. Next, accuracy is also there, 10 mm. So we can increase or decrease the accuracy. Next, this one number of triangles. Okay, so each swept volume for creating, it will divide it to small segments of movement. So it is initial 72, result 72. Next, wrapping, it is taking 20. We can change it to 100. Okay, click on preview. It is taking too much of time. Okay, ma. So after completion of this one, we are going to start our main basic formations. Okay, like this we are going to see the swept volume. Okay, so finally, one thing you need to remember. So whatever the tools I have explained from the SketchUp to this DMU kinematics, they are basic needs of the those workbenches. Okay, we haven't seen so many different. So here we have also clash analysis. Okay, if one object is going to clash with another object, we can see them. So there are several options we haven't discussed. But so up to here we only covered basic needs. So there are several options not only in this workbench. So remaining workbench are also several options are there. Okay, so from one workbench to another workbench, we can change the object. See, previously we have taken this same object to assembly, and we can take it to kinematic, and also we can insert these parts to some other. We can open this entire assembly in some other workbench also. Okay, that is the use of hybrid design. Okay, basically whenever we are creating this part, we are going to select the hybrid design, right? So that is the basic use of, we can just insert the part to assembly and assembly to this DMA kinematic, and the same time we can insert them into some other workbenches by using hybrid design. Okay, so like this. So we are going to stop the session up to here. So I'm
This
starting the
conference
recording.
will now be recorded.
See, it is directly I'm going to again open the workbench also. You need to know how to open the surface. See, this is an empty space. Start mechanical design. You can create here. Generate workbench is there. Last before one. Generate sheet. It is not sheet metal. Right. Okay. So here shape is there now. So here in the shape, generate shape is there. Click on OK. So this is the in curves. You will get to see your helix. Okay. So click on helix. So it is asking the starting point of the helix. So I don't have any starting points. I haven't even created a single point. So I'm clicking on create a point. So along x direction I'm giving some 50 distance. Click on OK. Okay. So now this is the point I have created. Now it is asking the helix axis. This is my axis. Guys, my voice is inaudible. Okay. So next one, what I am going to do. So by default, by with 1 mm pitch, it will create some uh, helix. I don't want my helix in 1 mm pitch. I'm going to increase my pitch to 5 mm. Okay, and also it has given only total helix height is 10 mm only. Okay, I don't want it in 10 mm. I'm going to give some. I need to increase the height of the helix also. Okay, so like this I have created 50 mm height helix, and then we can give the angle also. So starting angle we can change. Okay, starting point we have started from the axis now, so that axis we can change. So for certain angle from x-axis we have given 50 angle. Okay, see, this is the starting point from the x-axis. Next, I need to from the starting to ending same diameter is there. I don't want same diameter. I'm changing taper. Okay, I'm giving some angle. For the second edge, I'm giving the angle. See, I'm increasing the angle the same way. It is changing the taper angle. So like this. So it is showing inward. For example, I don't want it inward. I can change it to outward, outer direction. Okay, like this we can give it helix. Clear, ma? Is it clear? Okay, ma. If you have any doubts, you can ask me.